Welcome to our channel Learning Math. In this video, we're going to learn about the study of variation in addition to the equations of tangents to some curves representing certain functions. Now let's start together. First of all, we're going to learn when do we have an increasing curve that represents a function, when it's decreasing, when it has maximum or minimum. Actually, when the derivative f prime of x is positive, then we can say that f of x is increasing. Like what you see here, we have an increasing curve. Here, the derivative f prime of x is positive. On this section also, we have an increasing curve. So here, f prime of x is also positive. And when f prime of x is negative, then we will have a decreasing curve. Well, when do we have local maximum or local minimum? If we have the derivative f prime of x equals 0, then we can say that f of x admits either a local maximum or a local minimum, according to the question that we have. Well, something else. What's the meaning of the derivative f prime of x? Let's have a certain image about the derivative. If we have a point A with coordinates x1, y1 that moves on a certain curve to reach a point B of coordinates x2, y2. The coordinates of A vary from x1 to x2 and from y1 to y2. Here we can say that the abscissa varies. We have here delta x, which is the difference in the abscissa, and delta y, which is the difference of the ordinates of A. We talk about the derivative when the point slightly moves, as if it didn't move at all. We have a little difference between the abscissas and the ordinates of this point. We call them dx and dy. Actually, the derivative f prime of x represents for us dy by dx, which is the y is f of x, so we say it's df of x by dx. It represents for us the study of variation. How did the coordinates of this point vary when it slightly moves on this curve? So f prime of x is the derivative df of x by dx, or dy by dx, where y is equal to f of x. Now let's have an example together. Here is a function f of x which is equal 3x squared minus 7 over 2x minus 5. First of all, what's the domain of definition of this function? Note that the denominator shouldn't be 0. So we should say that 2x minus 5 different from 0, then x is different from 5 over 2. So the domain of definition here is the set of all real numbers are unless the point 5 over 2. So x is different from 5 over 2. Now what about the limits of this function at the boundaries of this domain? When we have df is r minus 5 over 2, it means x varies from minus infinity till 5 over 2 open, union from 5 over 2 open till plus infinity. So we should study the limits at all the boundaries. First, limit for f of x at plus infinity, we should take the highest degrees of the polynomials on numerator and denominator. So it's equal to limit at plus infinity for 3x squared over 2x. Note that here we can simplify x squared over x, it's x. So it's equal to limit at plus infinity for 3x over 2. Here x tends to plus infinity, then 3x over 2 sure will tend to plus infinity. Now what about limit at minus infinity for f of x? The same. We take the highest degrees for the polynomials on both numerator and denominator. So it's equal to limit at minus infinity for 3x squared over 2x. Also, we can simplify x squared by x. We get it 3x over 2. Now, as x tends to minus infinity, 3 over 2x will also tend to minus infinity. Well, what about the limit of f of x as x tends to 5 over 2 minus and 5 over 2 plus? Note that when x tends to 5 over 2 minus, we can just replace x by 5 over 2. But here on the denominator, as x tends to 5 over 2 minus, 2x minus 5 will tend to 0, but it will be less than 0. So it gives us 0 minus. And when we divide by 0 minus, we will have it minus infinity. Note that when x tends to 5 over 2 minus, the limit is minus infinity. So here we have a vertical asymptote which is 5 over 2. As x tends to a constant, the limit of f of x is infinity, so we have here a vertical asymptote. Now what about limit for f of x as x tends to 5 over 2 plus, which means x tends to 5 over 2 and it's greater than 5 over 2. On the numerator, we can directly replace x by 5 over 2, but note that on the denominator, 2x minus 5 will tend to 0. But since x is greater than 5 over 2, so it will be positive. It gives us 0 plus. And when we divide by 0 plus, it will give us plus infinity. Why plus infinity here and minus infinity here? The sign of the numerator is positive. That's why the sign of this limit will depend on the sign of the denominator. So here when we divided by 0 minus, the limit was minus infinity, since plus over minus is minus. And here when we divided by 0 plus, its sign here is positive, and plus over plus, it gives us plus infinity. In both cases, we will get x equals 5 over 2 is a vertical asymptote to f. Well, here we have studied the limits. Now let's start by the study of variation to this function. Note that f of x is equal 3x squared minus 7 over 2x minus 5. Isn't it in the form of u over v? Well, what about the derivative when we have u over v? Actually, the rule gives us u over v prime equals u prime v minus v prime u over v squared. Well, let's start by it. So here we can say that f prime of x equals, on the numerator we have u prime v. U is 3x squared minus 7. What about u prime? The derivative of x squared is 2x. The constant, we multiply it by the result. So 2x times 3, it gives us 6x. Minus the derivative of the constant 7 is 0. So we can write it or not. It doesn't affect. Well, u prime v. We should multiply our answer by v, which is here 2x minus 5. Well, we have solved u prime v. We are still needing to solve minus, we copy it. Now v prime times u. The derivative of 2x is 2. Since when we have constant multiplied by x, if we have the derivative of ax, it will give us a. Since the derivative of x is 1, 1 times 2, it gives us 2. Minus the derivative of 5 is 0, so the derivative v prime is equal to. It should be multiplied by u, which is 3x squared minus 7. Now over v squared, note that v is 2x minus 5, so we write it here 2x minus 5 all squared. Now we just need to solve them. Note that 6x times 2x, it gives us 12x squared, minus 6x times 5, it gives us 30x. Now minus times a plus, also minus, 2 times 3, 6x squared, minus times minus plus, 2 times 7, 14. Over the denominator 2x minus 5 all squared, we keep it the same. Now 12x squared minus 6x squared, note that it's 6x squared minus 30x, we copy it the same, we don't have any other x to solve it with. And plus 14, we also copy it the same for the denominator 2x minus 5 all squared. Well, when we find the derivative of the function f, in order to perform the study of variation, first of all, we need to solve f prime of x equals 0. Why? In order to find the points where we should have a local maximum or a local minimum, we need to solve f prime of x equal 0. Well, note something, when we have a fraction which is equal to 0, then the numerator is 0. Keep in mind the denominator should never be 0, and in the domain of definition we have just written that x should be different from 5 over 2. Well, now 6x squared minus 30x plus 14 equals 0. Here it's a quadratic equation. We need to find the discriminant and the roots. So delta prime, since we have b is even, we can divide it by 2. Delta prime is b prime squared minus ac. We solve it, we get 141. Now we just need to find x1 and x2. x1, which is minus b prime minus radical delta prime over a, and x2 is minus b prime plus radical delta prime over a. We just solve them. We have b prime is the half of minus 30, so it's minus 15. Radical delta prime, so it's radical 141 over a. the coefficient of x squared, which is 6. We get x1 is approximately 0.5 and x2 is approximately 4.5. Well, something else. We need to find where is the function increasing and where it's decreasing in order to write the table of variation. First of all, note that 2x minus 5 all squared, we have an even power, so it's positive for every x belongs to the domain of definition. Then the sign of the derivative f prime of x, to detect where it's positive or negative, its sign will completely depend on the sign of the numerator, which is the quadratic equation that we have just solved. But in this quadratic equation, we have found the roots. Delta is positive, it's 141 delta prime. Then we can say that between the roots we will have the opposite sign of a, and outside the roots we will have the same sign as a. Now let's start by the table of variation. How do we write it? First of all, we put x, f prime of x, and f of x. X varies from minus infinity to plus infinity, but we should write the roots x1, which is 0.5, and we should keep in mind to write the main condition at 5 over 2. We should write x equals 5 over 2, which is 2.5, and the second root x2, which is 4.5, and plus infinity. Sure, first of all, we have it not defined at 2.5, so we write it in this way. And at the roots x1 and x2, we have f prime of x is 0. Before completing, we should know something. To write the values for x, the main values for this function, we should write them from the least to the greatest one. So minus infinity, then 0.5, 2.5, 4.5, and plus infinity. We write them in an increasing order. Now, as we have just said that delta is positive, delta prime, sorry, we have a is equal to 6 positive. We have outside the roots, it's the same sign as a, and between the roots, it's opposite sign as a. So we can say that the derivative f prime is positive from minus infinity to 0.5 and negative between 0.5 and 4.5, the two roots, and it will be then positive from 4.5 till plus infinity. Now, wherever we have a positive derivative, we have an increasing function. And when we have it negative, then we will have a decreasing function. As you see here, f of x will be decreasing and then it will be increasing on this interval. Well, we should know from what value to what value it will be increasing or decreasing. Note that the limit of f of x at minus infinity, it was minus infinity. So it increased here from minus infinity till the maximum value here, which will be, since we have x1, which is 0.5, then f of x1, which is approximately 1.56. We solve it and we get it 1.56. Then it will decrease till 2.5, but it cannot be 2.5. Here is the limit at 5 over 2 minus, which is 2.5 minus. This limit, we have just solved it. It gave us minus infinity. Well, here it's also decreasing from the limit at 5 over 2 plus, which is 2.5 plus, which gave us plus infinity, and it will keep decreasing till f of x2, which is approximately 13.4, then it will increase till the limit at plus infinity, which gave us plus infinity. Now we can construct our curve. We should keep in mind here we have it a local maximum, if you note, and here we will have it a local minimum. Now to draw our curve, we should first of all put the asymptotes. We have the vertical asymptote at x equals 2.5. Now we start drawing our curve, which will be at minus infinity increasing till x1, f of x1, which we will put it right now, and then it will be decreasing to be approximately touching the vertical asymptote x equals 2.5. Then it will be here at the other side from 2.5 plus, it will be decreasing from plus infinity till the point x2, f of x2, and then it will be increasing till plus infinity. Note that here we have the local maximum at x1 f of x1, which is 0.5, 1.56 approximately, and we have a local minimum at the x2 f of x2, which is approximately 4.5, 13.4. We have just detected them on the table of variation. Well, are we having something else in order to learn how to draw our curve? Sure, we should have. Note that here we should plot these points which are the intersection with x prime or x. To know where we should draw our curve, where should it pass, we should know these 2 points. Note that they are the intersection with x prime or x. Now what does x prime or x represent for us? Isn't it the straight line or the axis of equation y equals 0? Well, y is f of x, so here we have f of x equals 0. To know the abscissas of these points, we should solve f of x equals 0. We have given f of x is a 3x squared minus 7 over 2x minus 5, fraction equals 0, then the numerator is 0. So we need to solve 3x squared minus 7 equals 0, which gives us x equals plus or minus radical 7 over 3. So here it's at radical 7 over 3, and here it's at minus radical 7 over 3. Something else, we need to know the intersection with y-axis. Well, how to know it? At y-axis we have x equals 0. Well, to find y, we need to find f of x. So here y equals f of x, so it's f of 0. If we replace x by 0, we get it minus 7 over minus 5, which is y equals 7 over 5 equals 1.4. So here this point has the ordinate 1.4. Now finally, we are still needing to learn how to find the equation of the tangent at a certain point. If we have a curve like you see in the figure, and we need to find the equation of a tangent t to this curve at a point A having coordinates x0, y0. How to find the equation of this tangent? Actually, to find this equation, we have y minus y0 equals a into x minus x0, where x0 is the abscissa of A and y0 is the ordinate of A, while the slope of this tangent is equal to the derivative f prime of x0. Note that also y0, if it's not given, we can find it using y0 equals f of x0. Well, something else. If you remember from grade 9, the slope of a straight line joining 2 points A and B is tangent alpha, which is the opposite over the adjacent. So it's delta y over delta x. But what happens if this point slightly moves? Here we have it dy by dx. So the slope, that's why the slope of this tangent is dy by dx at the point A. So it's the derivative f prime of x A. It's the derivative of f of x at the point A, at the abscissa of A. Now let's have an example together. As you see here, we have a function f of x which is equal to radical x squared minus 4. We need to find the equation of the tangent to this function at a certain point. First of all, we have x belongs to minus infinity, minus 2 opened union 2 opened plus infinity. Now let's see the representative curve of f, find the equation of the tangent to C at the point of abscissa 4. We just have the abscissa, which is x equals 4. How to find this equation? First of all, we should start y minus y0 equals a into x minus x0. We have x0 is given for the abscissa. y0 we don't have it given, but we can find it using y0 equals f of x0, so it's f of 4. We can replace x by 4. So y0 is radical 4 squared minus 4, so it's radical 16 minus 4 equals radical 12, which is 2 radical 3. Now we are having x0, y0, we are still needing to find a which is the derivative f prime of x0. So it's f prime of 4. But first of all, to calculate it, we need to find f prime of x. We have f of x is radical x squared minus 4. Now, what's the derivative of radical u? Actually, the derivative of radical u is u prime over 2 radical u, where u is here, as you see, a function of x. It's here given x squared minus 4. So the derivative f prime of x is equal to the derivative of x squared minus 4. Derivative of x squared is 2x minus the derivative of 4, the constant, which is 0. So u prime, which is here 2x over 2 radical u. We copy 2 and radical u, which is radical x squared minus 4. Note that we can simplify 2 by 2, so we get f prime of x is equal to x over radical x squared minus 4. We need to find it in general, and now we can calculate the slope a at x equal 4, which is f prime of 4. Now we can replace x by 4 in this derivative. So a is equal to x, which is 4, over radical x squared minus 4, which is 4 squared means 16 minus 4. When we solve it, we get a equals 2 radical 3 over 3. Now we can just replace them by their values, so the equation of this tangent is y minus 2 radical 3 equals a, which is 2 radical 3 over 3, into x minus x0, which is x minus 4. Here 2 radical 3 is y0, we have just calculated it. Note that if we move 2 radical 3 to the other side, minus will become plus. Therefore, the equation of this tangent is y equals 2 radical 3 over 3 into x minus 4 plus 2 radical 3. Here we can expand and solve it more. Now, thank you for watching. If you enjoyed this video, like, share and subscribe for the continuity of our channel to support you by more and more information. Thank you for watching.